Now, this is the last portion of alcohol, phenols, and ethers chapter, and this is ethers. We have already know what is ethers. So ROR, this is carbon, oxygen, and carbon group is there, and where R is alkyl group. So, for example, this one CH3O CH3, this is methoxymethane. We have already know the nomenclature process for ethers, and this is CH3OC2H5. This is methoxyethane. So now method of preparation of ethers. So there are two methods of preparation. Number one, dehydration of alcohol. So ROH, this is R means alkyl group. OH, this is an alcohol. This is also an alcohol. There are two alcohol group combined to get ethers and removing a water molecule when treating with 433 Kelvin temperature. So similarly, this one example for this R means this CH3 group, CH3OH plus CH2OH combined to give CH3OCH3, and a removing of water molecule takes place when added or when treating with a 433 Kelvin temperature. So this is the process of removing of water. So this one. So remaining portion is what? R and RO. So the remaining portion of the alcohols combined to give ROR. The next method of preparation is Williamson ether synthesis, and this is an important laboratory method for synthesis of ether. And this is RX. R means alkyl group, and X is a halogen. So RONA. So this is alkyl group ONA, and this compound is called sodium alkoxide. Na means sodium, and the product is ROR, that means ether, and a side product of NaX is produced. Okay. For example, CH3Cl. CH3 means R group. Cl is a halogen atom, and CH3ONS. This is called sodium alkoxide. Or this is sodium alkoxide, and this is sodium methoxide. This is methyl group, so this is called sodium methoxide, and the product is CH3O CH3. This is the removing of sodium fluoride takes place, and the remaining portion CH3O CH3 is the product. And the next example, CH3CH2Cl. And this one CH3ONA, this is ethyl fluoride, and this is sodium methoxide. Important thing is that the symmetrical and unsymmetrical ethers both can be prepared from Williamson ether synthesis. This is symmetrical ether. When the alkyl groups when the alkyl group, both alkyl groups are same in the both side of oxygen, these ethers are called symmetrical ethers, but this ether is unsymmetrical ethers because there are two different alkyl group present in two different cells. This is unsymmetrical ether, and this is symmetrical ether. So both ethers can be prepared by this Williamson ether synthesis. This is ethyl fluoride, and this is sodium methoxide. Okay, and sodium fluoride molecule will be removed from these two molecules, and remaining portion CH3CH2OCH3. This is the product, and this is the side product. These are also the examples of Williamson ether synthesis. This is alkyl halide, and this is sodium methoxide. And when treating with both, the product is ether is produced, and side product is sodium bromide. And this is the side product, sodium bromide, and the remaining portion CH3CH3. This C will attach to this oxygen, so COCH3. This one COCH3, and the remaining portion are NaBr. This is the side product. Okay. The next reaction, this is phenol. And when phenol is reaction with a sodium hydroxide or potassium hydroxide, then sodium phenoxide is observed. This is sodium phenoxide, and this is also sodium alkoxide also. So when sodium alkoxide is treated with another alkyl halide, then this sodium halide is removed, and the remaining portion phenoxide OR, this is the ether. Okay, and this is the side product, sodium halide, sodium chloride or sodium bromide. Okay, next topic, physical properties of ethers. So number one physical properties, we will discuss about the solubility. Okay, so ethers are soluble in water because ether is polar molecule due to the presence of oxygen atom in the ether molecule. This is polar, and water is also a polar molecule. So water, ether is dissolved in water due to the formation of hydrogen bonding between ether and water molecule. These are the hydrogen bonding, and these are also hydrogen bonding, and this is ether molecule and this is water molecule. These are hydrogen bonding formation between oxygen and hydrogen, oxygen atom of ether molecule and hydrogen atom of water molecule. So ethers are soluble in water. So next point, boiling points. So there are many difference in boiling point between hydrocarbon, that means butane, means alkane, this is ether, this is ethoxyethane, and this is butanol. And these are the compounds we have taken having the comparable molecular mass, that means same molecular mass about butane, ethoxyethane and butanol. There are 4 numbers of carbon atom, 1, 2, 3, 4, and there are 4 numbers of carbon atom. And the boiling points is different in butanol. This is alcohol compared to ether and butane, because there is a formation of possibility of hydrogen bond in case of 2 molecules of butanol, but it is unable to formation of hydrogen bonding between the molecules of butane and as well as between the molecules of ethoxyethane. So boiling points of butanol, that means alcohol, is much more greater than the ethoxyethane, that means ether, and butane, that means hydrocarbon. Okay.